in this video, I'm going to talk to you about uncertainties and about the effect of uncertainties on experiments that we may carry out. So anytime we carry out an experiment, there is going to be some uncertainty in our results, and that's for a number of reasons. Basically, there are two types of uncertainties: random and systematic uncertainties, and these both have an effect on the accuracy of our result. So I want to talk today about accuracy, random uncertainties, systematic uncertainties, and then some things we can do to reduce the effect of these uncertainties. So let's start off with accuracy. Now, what do we mean by accuracy? Well, accuracy is a term that we use to denote how close our value, the value that we come up with from an experiment, is to the true value. Now we know, let's say we're carrying out an experiment to work out the value of the acceleration due to gravity. Okay, so this could be setting a pendulum in motion, working out the time period of that motion and plotting the time period against the length of the pendulum. From that you can work out the acceleration due to gravity. So we've carried out that experiment and we get a value of 9.52. Okay, so that's the value that we come up with from our experiment for the acceleration due to gravity. Now we know that is not the correct value. Okay, the true or correct value is 9.81, and that's been established over hundreds of years through probably hundreds or thousands of experiments being carried out to a high degree of accuracy. So we know that's the true value. So there's clearly some difference between these two values, and that is because there are uncertainties in experiments that we carry out, and they affect the accuracy of our result. Okay, so this result is not entirely accurate. So the closer this result is to the true value, the more accurate it is. All right, so that's what we mean by accuracy. Now the question is this result accurate? How do you know if a result's accurate? How close does it have to be to the true value to be considered accurate as a scientist? Well, usually we say that if a result is within plus or minus 5% of the true value, then it's accurate. Okay, because all scientists agree that you're never going to get a result that's entirely accurate, or it's very difficult to get a result that's entirely accurate. So anything that's within 5% of the true value, we say is accurate. Okay, so is our result accurate that we've calculated here? Well, the way we can do this is, let's work out 5% of g. So g is 9.81 meters per second squared. Okay, so 5% of that, well, 10% would be 0.98. Okay, so 5%, or 0.981 maybe you could say, so 5% will be 0.4905. So we'll just say 0.49 there. Okay, so 0.49 meters per second squared, that's 5%. Okay, so if we take 9.81 and minus 0.49 from that, then we're going to get 9.32 meters per second squared. So that's the lowest value. Anything less than that would be considered inaccurate. Now, since our value is 9.52, okay, it falls within the accepted range for an accurate value. So we can say that this value, even though it's not completely accurate, is considered accurate in the scientific community because it's within 5% of the true value. Okay, so that's what we mean by accuracy. Now, there are two things that affect accuracy. We've got random uncertainties. Okay, so random uncertainties affect any result that we take. All right, now perhaps before I talk about random uncertainties, we need to talk about the resolution of instruments. So let's do that first of all. Okay, so the first thing we could look at is perhaps a ruler. So if you take this ruler here, you can see this is just a standard centimetre ruler, 30 centimetre ruler. And on this ruler here, you can see the divisions. So that's 1 centimetre, 2, 3. But within those centimetre divisions, there are smaller divisions, and these are 1 millimetre divisions. So we say that the resolution of this ruler, its resolution, okay, is plus or minus 1 millimetre, because that's the smallest reading that it can take. That's the lowest division on this ruler. You could also say that it's plus or minus 0.1 centimeters, because this is 0.1 centimeters, 0.1, 0.2, 0.3, 0.4, 0.5. So 0.1 centimeters. Or you can put it in meters, which is plus or minus 0.001 meters. Okay, that's the same thing. They're all the same. Those values there. They're just in different units. Okay, or not different units, but different multipliers there. Right, so that's resolution. That's the resolution of this ruler. Now, the resolution of a meter ruler that you would use in the lab would be exactly the same. That would also be plus or minus 1 millimeter, or 0.1 centimeters, or 0.001 meters. If I just take this standard measuring tape here, for example, okay, we'll ignore the numbers on the top. That's in inches. But if you look at the bottom here, this again is in centimeters. 3, 4, 5, 6, 7 centimeters, and again you can see that the divisions here are 1 millimeter. So most rulers, meter rulers, standard rulers that you'd use in class, they measure to 1 millimeter. So that's their resolution. It's the smallest reading they can take. You do need to watch out though, because sometimes in certain experiments we use rulers that only have a resolution of 1 centimeter, but that's unusual. Okay, let's have a look at another thing then. So another piece of equipment that we often use in the lab. So here we've got a multimeter. Now, if I turn this round to the 10 amp scale, that's a scale that we often use, you can see that this will read to 2 decimal places. So the smallest reading this will take, this multimeter, is plus or minus 0.01 amps. Okay, because it reads to 2 decimal places. If we look at it on the volt scale, the 20 volt scale, when it sorts itself out there, you can see that this will read to plus or minus 0.01 volts. That's the resolution of this multimeter. But if I turn it onto a different scale, the 2 volt scale there, you can see now that it's measuring to 3 decimal places. So on that scale, the resolution is 0.001 volts. But usually we use these sort of scales. So usually a multimeter reads to plus or minus 0.01 amps or 0.01 volts. Okay, so that's a multimeter. Now, if we look at, for example, a stopwatch, let me just see if I can get that up and running on my phone before showing you. Should have sorted this out first. So stopwatch, here we go. Now, the stopwatch you can see here is running. If I stop this, you can see that this stopwatch on my mobile phone, it's exactly the same as any stopwatch you would use in the lab. The time here is equal to 5.98 seconds. So we know that the resolution of this stopwatch is 0.01 seconds, plus or minus 0.01 seconds, because it reads to 2 decimal places. So that's the smallest reading it can take, the smallest division. So that's what we mean by the resolution of the instrument. The resolution of an instrument that we use to measure something is the smallest measurement that it can make. Okay? And the resolution of instruments affects how accurate our results are. All right? So that's resolution.